the core practical we're going to look at today is an acid and alkali titration. So it's a neutralisation reaction that's happening between the acid and the alkali. We've got some equipment here that you may not have used before. This is a burette. It measures volumes. It's just more accurate. It's a more accurate way of doing that. We've got the conical flask and a white tile. You'll see why we need the white tile in a moment. And we've got a glass pipette with a pipette filler, which helps to fill it. So, the acid we're going to use today is hydrochloric acid, but we don't know the concentration of it. That's the point of the practical. And the alkali we're going to use today is sodium hydroxide, and we do know the concentration and the volume of that. So the first thing I'm going to do is fill the burette. Now it's already been rinsed with the acid. We do this to try and avoid any contamination. And we need to make sure that the tap at the bottom is horizontal, that it's perpendicular to the burette. If it's in line with it, then it will all come pouring out as I try and put it in the top. So we'll make sure that that's tight there. And then I'm going to fill from the top of the burette into the funnel. We must make sure that we're wearing goggles for this in case the acid splashes into our eye. And we're looking to get the measurement right on 0. We want the bottom of the meniscus, the little dip, to be onto the 0 line. And then we can take the funnel out. So the acid is ready to be added there. And so now we need to measure out the alkali. We know we need 25 centimetre cubed of this, and this pipette measures only 25, which is why it's so accurate. So we fill to this very fine line up here with the pipette filler. In the olden days, they didn't have pipette fillers, they had to use their mouths, which I wouldn't do today. And again, you need to make sure that it is right on, the meniscus is right on the line. Okay, and then we can transfer that into the conical flask. So because both of the chemicals we're using today are colourless, because they are both soluble substances, we need to use an indicator which is going to show us when the neutralisation reaction has happened. So there's two indicators we could use, methyl orange or phenolphthalein. We can't use universal indicator because it has a range of colours, and that's not going to be precise enough to tell us when the reaction has happened. So the one we're going to use today is phenolphthalein. We'll just put a few drops of it into here. It goes a nice pink colour. I can put that underneath the burette there on this white tile. The white tile is there just to show us the colour change more clearly against the background of the table. So we can now start to titrate. So we'll turn the tap, swirl as we go, and we can go quite quickly towards the beginning to make sure we've got enough H+ ions in there to neutralise the OH- ions in the conical flask. Swirling to make sure that it's all mixed in nice and evenly so that we don't get a delayed reaction. And then when we get near to around 20, I'm going to go a little bit slower. At the neutralisation point, with this indicator, it's going to go colourless. Okay, that's around 20, so I'm just going to slow the drips down a little bit, because it is going to be one drop that's going to make all the difference now. Just starting to creep through. Just need to wait for a uniform colour change. And there it is. At this point we may want to rinse the end of the burette with distilled water just to make sure there isn't any excess acid on there, to make sure it's all coming. And then we can note down the volume on the burette, which this one is reading at 23.8 centimetre cubed of acid. This was a rough titration. We know that it's roughly going to be around 23, so we're going to repeat the titration now and do it another 2, 3, 4 times, as many times as it takes to get 2 results that are concordant next to each other within 0.2 centimetre cubed of each other. And so we will repeat this again, filling up the acid again to the top, remeasuring another 25 centimetre cubed of sodium hydroxide.